9.2, what we're going to be looking at is the sum and difference identities. And so the first kind of thing I want to say here is that the word formula and identity, we're going to be using quite a bit throughout this section, and they can replace each other as we go. As we work with some identities in this section, like we saw in the previous section of different identities we are proving, working with, and manipulating with, I do want to reference number one, this unit circle. This has been referenced in chapter 7, so hopefully this is kind of becoming familiar to you. Just remember that with this, the main thing you need to remember is this first quadrant here, and then it's symmetrical over the 4 quadrants. You really are essentially only working when you're looking at the fractions with 3 different values and moving them around. You do need to be aware of your angle values in radians and degrees. And then also remember that these XY values are ordered pairs in relation to our unit circle, which has a radius of 1, but it also refers to the cosine or sine of the given angle. And so I'm going to be referencing this as we go. So just be aware of that. This is where the values are coming from. Either have these notes or a unit circle handy from the textbook, or just Google unit circle. And that is going to benefit us a lot as we move forward. So what we're going to be doing with the sum and difference formulas is we are going to be looking at how we can basically break apart and put together different trig functions to bring it all back to our basics of the unit circle. So we're going to be finding exact angles of sine and cosine, and we can do that if we're able to break it down into 2 angles that we know, such as angles here on the trig circle. So what I want to do is I want to go ahead and kind of get started here, and I want to look at these sum and difference identities. So I have a nice box here from your textbook identifying these. Now there are some really great proofs in your textbook with a breakdown of how they started with this and prove how they got to the other side, similar to what we did in section 1. But I didn't want to go through 2 or 3 pages of that here and proving these, but if you refer to your textbook, there is some nice proofs that you can glance at there. So we're going to be working with cosine and sine and even some other functions today, some sum and difference identities. I mean, it's the name of our title of our section. And so what I want to do is, here's our 2 identities. Hopefully you've printed off these notes before we got started, or you're jotting them down as we go. Pause this video when you need to. Cosine of alpha plus beta, we can see it's broken down. And then cosine of alpha minus beta, we can see how it is broken down. What I want to do is for each of these sum and difference functions, I want to identify for you the identities or formulas. I want to show you a process, and then I want to work through some examples. And then at the end, we're going to put it all together. So here are the 2 identities that we first get for the day, and here's our how-to. How are we even going to use these? If we're given 2 angles and we want to find the cosine of the difference between them, so we're going to first start with that, we want to write the difference formula for cosine, substitute the values of the given angles into the formula, and then we're going to simplify. So let me show you that here with this first example. Find the exact value of cosine of 5 pi over 4 minus pi over 6. And so let's remember here that cosine of alpha minus beta is equal to cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And that's just from what you see up here. Now, considering this, this is going to be my alpha and this is going to be my beta. So this is going to be equal to cosine of 5 pi over 4, cosine of pi over 6, plus sine of 5 pi over 4, sine of pi over 6. Now, referencing back to your unit circle that we were referring to earlier, I'm going to come on here and I'm going to look and I'm say, okay, well, I'm looking for something in relation to 5 pi over 4. Now, remember, cosine, comma, your sine value, they're alphabetical, just like your xy coordinate is. So if I'm looking for cosine of 5 pi over 4, here it is. Then we're going to go for cosine of pi over 6. So I'm going to come up here to pi over 6, and there's the cosine of it, and then use the sine of both of those as well. So all 4 of these values are located on my unit circle or trig circle. I'm going to come in and fill in those values as we just located. So negative square root of 2 over 2, square root of 3 over 2, plus negative square root of 2 over 2, 1/2. Now, use all my fraction rules for operations. And so this first one turns into the negative square root of 6 over 4, plus the negative square root of 2 over 4, same denominators. So I can put this together to give me negative square root of 6 minus the square root of 2 all over 4. And we will be leaving these as exact answers as we work through these. So you can see here that with just this first example here, I identified my alpha, my beta, I wrote my identity, plugged in my alpha and betas, referred to my unit circle, and then finished out my arithmetic. Now let's go to one that is not as straightforward as that. Let's look at the cosine of 75 degrees. Now, if you go to your unit circle, you can see that cosine of 75, I've got 60 degrees and 90 degrees, so I'm trying to find 75 degrees somewhere in here, which is not on my trig circle. So I'm going to have to use this identity for this one and break this apart into something I do know I can work with. So if you consider 75 degrees, this is equal to 30 degrees plus 45 degrees. Now, a side note here, we could consider 75 being the equivalent of 135 minus 60 and getting 75, and that would have been fine as well. Either way will get you there. But I'm going to work with this one on the addition because here we use the difference, and so I want to do a sum one. So instead of cosine of 75 degrees, I'm going to consider this as cosine of 30 degrees plus 45 degrees. Applying the identity that we saw up here, we can see that we're going to be doing cosine alpha, cosine beta minus sine alpha, sine beta. So I'm going to come down here and I'm going to say, okay, well, here's my alpha and here's my beta. And so this would give me cosine of 30 degrees, cosine of 45 degrees, minus sine of 30 degrees, sine of 45 degrees. Now this isn't bad because if I go back to my unit circle, here's 30 degrees. I can work with that. There's my cosine, there's my sine. And then 45 degrees, there's my cosine, there's my sine. So I'm going to use these values to plug in to this identity that I've created. So this would give me square root of 3 over 2, square root of 2 over 2, minus 1/2, and square root of 2 over 2. Simplifying that up, this gives me square root of 6 over 4, minus square root of 2 over 4. So finishing out with square root of 6 minus square root of 2 all over 4. So you can see that this in its process and steps is similar to what we did up here, but we had to take one initial step, separate out the given angle into known angles, and then apply our identity from there. So let's move on and let's look at a different one here. Go back up here on number 3, and we're going to be looking at the sum and difference formulas for sine. Now, the proofs are very similar for these sine function and identities. Again, you could reference back to the proof for the cosine within your textbook, and it would be very similar. So we're just going to go ahead and take these as truth, and we can see that here's our sum, and here's our difference, and the breakdown. And so just like with cosine, I'm going to take some similar processes and steps to get there. So part 2 here, processes and examples. We are going to write the difference formula for sine, substitute the given angles into the formula, and then simplify. Very much like we just did with cosine. So number 1, here's how the instructions may be worded. Use the sum and difference identities to evaluate the difference of the angles and show that, we just want to look at part A. I took out part B. So we're going to be looking at sine of 45 degrees minus 30 degrees. And so I can see that this is a difference. And so I'm going to refer back up to here and be using this identity as I go. So I'm going to say sine of 45 degrees minus 30 degrees is equal to, now remember we had sine of alpha minus beta up there, was equal to sine alpha cosine beta minus cosine alpha sine beta. I'm going to plug in those accordingly. So let's see, here's my alpha, here's my beta. So I'm going to say sine of 45 cosine of 30 minus cosine of 45 sine of 30. And again, I'm going all the way back to my unit circle, pulling it up from the very first page of our notes. We're looking at 45 and 30, just like we were in the beginning, the example right above this. And so this would give me square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times a half. Simplify that up, square root of 6 over 4 minus square root of 2 over 4. So square root of 6 minus square root of 2 all over 4. So you can see these steps are very similar. I just had to identify my alpha and beta to get me going. Now in this next example, we need a little bit more room to get us going. You can see that this is arc functions in here, and based from chapter 8, we know about arc functions. We know that arc cosine of 1/2 means the ratio is 1/2 of a given angle, and arc sine of 3/5, this is the ratio, which is referring to an angle. And so what I want to do is I want to turn this into my alpha and my beta. So I'm going to let this be alpha and this be beta, so I have sine of alpha plus beta. And so let me just kind of write out to the side what I have. I have alpha is equal to arc cosine of 1/2. So if I reverse this, this would give me cosine of alpha is equal to 1/2. Similarly, I'm going to work with beta. Beta is equal to arc sine of 3/5. And so if I reverse that, I get sine of beta equal to 3/5. Now this is all well and good, but we know that when we're working with sine of the sum of these, that we're going to have sine of alpha and we're going to have cosine of beta. So what we're going to do is we are going to use our Pythagorean identities to help us get there. So remember this, and I'm going to work with this first one here. Remember that we know that sine squared alpha plus cosine squared alpha is equal to 1. I'm going to solve this. This gives me sine squared alpha equal to 1 minus cosine squared alpha, moving this over, and then square root both sides, and I can see that sine alpha would be equal to the square root of 1 minus cosine squared alpha, which that's what we're trying to find, is that sine alpha. And again, over here, we're trying to find our cosine of beta. And so I have enough information to solve this out, and so I'm going to say, okay, well, then that would be equal to 1 minus cosine squared alpha. So here's cosine alpha equal to 1/2. So I'm going to say 1/2 squared. So it would be 1 minus 1/4, which would be 3/4, which would be the square root of 3 over 2. So I could say that sine of alpha is square root of 3 over 2. Now if I can find this last piece here, I'll have enough information to execute this. And so similarly, I'm going to say sine squared beta is equal to cosine squared beta, sine squared beta plus cosine squared beta is equal to 1. Solve that out, and that would give me cosine beta equals the square root of 1 minus sine squared beta. Plug in everything that I know. So this follows the same path. I plug in everything I know like I know here, so it gives me 1 minus 3/5 squared, which will be 1 minus 9 over 25, 16 over 25, or reduces down to 4/5. Now that I have both of my sine and cosine of alpha, my sine and cosine of beta, I can come down here and say, okay, well, if I'm looking at sine of arc cosine of 1/2 plus arc sine of 3/5, let's call that sine alpha plus beta. So that means I'm looking at sine of alpha cosine beta plus cosine alpha sine beta by my identity. Plug in all four values that I know, so square root of 3 over 2, and this is all from above, 4/5, 1/2, 3/5. This simplifies out to 4 square roots of 3 plus 3 over 10. And so you can see that with all of this, we use what we knew about arc functions to figure out the data that we had up here. We used Pythagorean identities to figure out the unknown ones we didn't know. And then we used our sum and difference to help us to execute the problem.